Well, alright. This was the Color Cube project, and it was originally for a church's kids program. And what it was is a 3-foot cube filled with lights. Let's see, it had 192 cells in it, and each cell would be a square in it, and each cell had 6 LEDs, 2 reds, 2 greens, and 2 blues, for a total of 1,152 LEDs. And so, me and a lot of guys from this church got together and just soldered and soldered and soldered and soldered, and I wrote the program to make this whole thing come together. So, just to show you more about it before I get to the real program, which is why you all are here anyhow. This was just some pictures I took of the whole apparatus as it was. It was just filled with boards and tons of wires. And then this is all the soldering and whatnot we did. And I designed the board, I wrote the chip program, and I wrote the Visual Basic program right here. So here's this Visual Basic program, and basically, as you can already tell, all these squares represent each cell on the cube. And so if I wanted to say color something red, I could just, or green actually, select green and then just click, 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 click. And then by scrolling through the scenes, which is each frame if you will, it would adjust them accordingly. And with that, the way I sent out the data to the cube was by a COM port, but it was more specifically a USB to something called an FTDI. And what FTDI does is it will go, what's it called, USB to serial. Let's see, and you can get one of those at sparkfun.com, which is also a great company, by the way. You can get a lot of fun stuff here. So if I go to, once it loads, ever so slowly, darn it, FTDI, okay. And yeah, one of these guys. And what it basically does, it has a USB in one end and something called a TTL out the other, which is basically it's serial. And it's really cheap, only for like 15 bucks, real simple. And if you know how to do microchips, as in PIC microchips or Arduino, then you would use something like this to have your Visual Basic talk to your controller device. So let's get back to this program here. Now you can see a lot of different functions and crap on here. And so the idea would be that you would set up a new file here. You could have set a number of scenes. You could have 50 scenes, and each one would take 100 milliseconds long. And you can start at scene 1. You could have a green here and a green there, and a scene 2 would have a green there and a green there, or whatever you pleased it to be. So that when you hit start, it would actually go through each scene and play what you showed. So there it is. Okay. Now there's some other little fun things I put on here. Mouse tracks was supposed to have been something where you move your mouse over the cubes and it does its thing. I don't think I ever really got that finished. Another cool thing I had was insert text, RoboMat, which it kind of fills it in for you. So there we are. So that way you could shift it around and it would keep its text in there. And then I have a list where you could actually save all of these animations. Each animation had its own list, so I could load this guy up and start that at a 500 millisecond pulse. It would do this animation, and then once you could save it, you could put it into a list. Let's see, do that, do that, do that, do that, and that guy. And so you could start playlist, and actually you could have a whole playlist going for the event that would be using this cube. So I did all this, and unfortunately, from some people not liking other people, the project got canceled. Didn't get to keep the cube either, but here is the program, and I figured you all would love to see a huge project like this. And this project is 1,700 lines of code, not including the 2 chips that I used as well. And by 1,700, that's, I scroll to the bottom of this big program, and the last line is 1,756. But that also includes all the spaces between that weren't totally used. So, for I guess a brief basic overview of how I did this whole thing. Usually what I like to do for a to-do list is I put it right at the top, all in comments at the top of my thing. So every time I open up the thing, it'll say, oh, hey, this and this and this, how about this? This would be good, kind of thing. So I put it all up there. So this isn't too advanced of a program since I wrote this probably 1 to 2 years ago. I just figured, big program would be interesting to see. Now, of course, I'll put this all up on it'll be in the description, the link to where you can get all this code if you have, such the need to use it. So anyways, it grabs a list of all the serial ports, and let's see, it defines a whole bunch of bitmaps, since if you look at here at the setup, you don't see any of those squares in there. That's because all those squares are all actually originated by code, which is one of the new things I learned when doing this program, was how to make form controls by code. And so there's 192 of these suckers, and this defines all that crap. Alright, and then CS would be the chip scenes, which is a bit array of a lot of stuff. Let's see, this is for saving stuff and some more stuff. Alright, so on the first load, which I call this program multi-light, by the way. So on the first load, I found all the serial ports, and let's see here, I added them all to, oh yeah, serial port. This is something new. You can add a serial port to your program, and it basically is saying COM1 or whatever COM you want, and then all the stuff about it, like baud rate and all that crap. So what we want to do next is kind of, I guess, set it up and kind of then not worry about it. Then we add from serial list, which was defined up here for all the port names, add that to this combo box, which was this guy, and also add the word test. Now, test allowed me to not send data, but just simply to test the data or test the animations out before I actually was hooked up to the cube. And then control int initiate or what have you. That is basically the making of all those picture boxes. And so you can see here I defined some stuff for it, and then for 1 to 191, or it's really 0 through 191, which is 192, I tell it what it is, enable it, give it a name, give it a size, make it visible, give it a back color, and make it a parent, or give it its parent. And parent is important, by the way. If no parent, it doesn't show up, interestingly enough. And then for the left face, I make a little kind of loop here where I say if you are this big, then you shall be in this position. I call them both left face. So one of these is right face. I don't know which one it is. Let's see, 170. Oh, it's probably right face then, so this gotta be right face. And then bottom face. Now the cube was meant to actually be suspended in the air, so that you only could see the front 2 faces, and then the bottom face would be visible, but it would be tall up, so you actually wouldn't be able to see the top of the cube, and the back of it would be kind of covered as well. So you could think of it kind of like it was attached to your ceiling in the corner of the room, is how it was kind of meant to be set up. But I always had to do it upside down because I wouldn't really be able to see it if it were on its face. Anyways, I then add some handlers to each kind of picture box there. If mouse down happens, then call address pick handler. If the mouse entered or exited it, which would have been used for the mouse tracks thing, then start a PB enter or PB exit. And then finally we want to draw the graphics inside of it to draw the number of the square that it's referring to. See how each one of these has a 0, 1, 2, 3, 4, 5, 6, 7, and down here 189, 190, 191. That's what this code is doing. It's actually drawing those strings into those picture boxes. So on, let's say, a picture box was clicked, then we can tell which one was clicked by using bival sender, and the picture box is the sender type of picture box. Let's see, pick index, yeah, pick index right here. Pick index was the picture box within sender, and it gave me a number returning to me which one of the 0 through 191s were picked. And so, let's see here. This is basically choosing the color. And so, if radio button whatever, radio button would be all that junk over here. Then if that one is picked, then draw that with that color, and then change the data appropriately, because now we're not going to read these colors every time. We're actually going to put them into the data and then read from it, whether we're either choosing a new scene or what have you. And that was held up here as a global variable, the CS chip scene. Alright, probably best if I do that. Start stop button, pretty simplistic. It just, enabled and disabled things. Let's see, send. I guess this is where the rubber meets the road, if you will. Compiled bytes was after, since CS was a huge list of bits, it had to be converted into bytes, and that's what these guys did right here. There probably is a simpler method to compile bits into bytes, but at the time I didn't know it, and I haven't looked since, to be honest. But basically it creates an array of bytes and then does like this shift thing where it shifts them all into the compiled bytes. And so finally at the end of this big loop, we clear the serial port and then write the serial port for let's see, write the serial port for that byte at this offset for one byte. And if anything fails, it says send failed, get branded. Something happened that shouldn't have happened, and no one else really, I guess, would have known how to do it. So I should have put my phone number on there too. Why not, right? And so this would be ever ticking timer. What did I do with this? It's been years, man. It's been years. Anyhow, I guess this kind of set up the serial port, looks like. So I'm not going to worry about that. And then timer number 2, this guy had to be the send timer. And he was being modified. See, time in milliseconds had to have been in the code changing timer number 2. And I could probably find that. But there's a lot of stuff here. I'll get to that eventually, I guess. So, for each count, and counter would have been, which scene we're on. Counter would have been, oh man, all this garbage. You see, big programs like this are just a lot of issue to figure out later, years later. But anyways, I can see this was also handling the playlist thing that I had over here, this data grid view. And so if you're wondering how to do data grid view, I guess you look at this guy to figure out how I did it. But data grid views are great form control items that you can use for large amounts of data. Anyways, forget that. This wouldn't let the current scene go over the maximum scene. Scene change, if you were to click up or down on scene, it would then change all the images that were in the faces here to be the scene you were currently looking at. And this would have been the code to do that, where it pulls it out of the CS, these chip scenes, and put them into the picture boxes. Let's see. Oh, okay. So this, if the numeric value changed, then call change scene. Let's see. Oh yeah, mouse wheel. I used the mouse wheel as well because it became tedious after a long time to, you know, click here, then click, 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 and then click here, then click, 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 click. Where I was doing something where I wanted to go, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9. I use a mouse wheel, click, scroll, click, scroll, click, scroll, click, scroll, and make it quicker. So the mouse wheel, using the E, which is a mouse event arguments from the mouse wheel happening, that the mouse wheel would then change the numeric up-down value and then use call scene. So that was quite handy. And then if the scenes were similar to each other but needed maybe to shift over a little bit, I had these two buttons right here, copy from previous and copy from next. So I could put a green dot here and move over with my mouse wheel or clicking this to the next scene, and then copy from previous, and would copy that green dot over from the previous scene or from the next scene. And so that's what copy previous and copy from next was. Load. This was a let's see, this was this was, I don't know, stuff. What was I doing here? It's probably this load right here, where I could choose something from this list and it would find it and bring it into there. Now, interestingly enough, there should be something around here that actually looked, file list. It was a list of files that searched for MLF, which was multi-light file, and it put it into a array of strings called file list right there at the beginning, so that for all the selected files in the file list, I could then bring all those up and fill in that list box. So when you clicked on one of them and hit load, it would throw all that data into CS with our chip scene. So there we are. Now save similarly would take the current chip scenes and dump them into a file, and then that was that. So if you want to know how file saving can work, you can look at this for reference, or I made a video on how to actually save and modify files, and that may be better reference since that was more recent than this program was made. I forget what refreshes is. Oh yeah, I see. If for whatever reason this list here changed, you could hit, or in your file structure, if you just copy one over and you wanted them to appear in here, there wasn't any kind of ever ticking timer to, you know, keep watch over that. So you hit refresh and it would refresh the list here. Okay, there's that. Yeah, let's see. Oh, new. Basically cleared everything out. Okay. Shifts. Oh yeah. So if you wanted to shift your whole image up, right, left, or down, there you are. These were the buttons to do it. This is how I did it. This took a lot of time and a lot of extra hand work here to figure that one all out. So that was shift right, shift left, shift up, and shift down. Yeah, lots of work went into that one. Mouse tracks. I really don't know what to tell you about this since I couldn't get it working. Oh, I see. Serial port had been open. Oh well. No worries. It basically follows your mouse. If your mouse entered, see here, this is the PB enter from above, the add handler that we had. If a mouse enters, then whatever radio button was checked, that's the color it showed. And then once your mouse left, it put it back to its previous color, or black, whichever. And now this guy, insert text, this was basically, because it was for a church, I was thinking you could put like Bible verses on there, so I had all the lowercase letters, the uppercase letters, and numbers, and I think I had like a colon in there as well. Yeah, all bunch of different kinds of characters. And basically what it does is it puts these numbers into an array, and with that array then draws that array onto the current scene. So each of those numbers represents the pixels of the letter. And let's see, there was something. Oh yeah, this also kind of spaced them as well. So if you had an ROBO Robomatics kind of thing, it would put the O spaced and after the R, and the B spaced after that O. So it all spaced it all out. So I could just basically make these as a single point in space, and then space out appropriately. That was a lot of work too, because I had to do that all by hand. Probably easy methods for everything I've done here so far. Like I said, it's all a long time ago. This was the animation playlist, and here this is the data grid stuff you can take a look at if you wanted some data grid view things. And so anyways, if I wanted to add something to playlist, add to playlist, let's see, that would have been this button right here, to list. Yeah, push button 13. Okay. So anyways, it would add that to the list, and oh yeah, there was something else on there called repeat. Like if I put that in there, repeat, it should repeat like 2 or 3 times after you hit play. Like I can, oh, okay, start playlist. Oh, wait, gotta put the test first. Huh. Can't remember how I wrote my own program. Now, see, it'll do it twice here because I put it twice. And repeat was supposed to, if I put 2 in here, it should just, you know, play it twice. However, I never really got that to work. So, I could shift the pieces of the animation playlist up and down if I made a mistake. So that's what these two are. And I could delete the row if I needed to, if I didn't want it. This is the start button for the animation playlist. It just kind of enabled and disabled things. And then you could also add a pause where, say, the guy wanted to talk for a while. After the animation was done, it would sit there at the pause and hold there. And then once it was done, you could hit the continue button and it would take off again. And that's what this was here, the continue button. That kind of just kept going on the playlist. So anyways, that is the giant program I wrote for the big light cube that unfortunately never really truly got used. It's unfortunate. Let's see. Well, that's about it. So I hope you can find something that you can use from this, maybe a reference you can pull up for later if you like some of the components I used in here. But yeah, there you go. Have fun with that.